Hello there, students. Let's talk about calculating percent yield of a chemical reaction. We saw in the previous video where we were confronted with a situation where we had two reactants in some number of grams and we had to determine which reactant was the limiting reactant, because I can only make as much product as I'm limited by. So the limiting reactant or reagent will be consumed completely in the chemical reaction, while the other reactant will be left in excess. Some excess of the other reactant will be left. Okay? Now, your percent yield calculation is based on two things. The actual yield, that's the amount of product you collect after the reaction has taken place, and the theoretical yield, which is the maximum amount of product you can make. We can calculate the theoretical yield before we even perform the reaction. The actual yield comes after the reaction is complete. It's the amount of product we actually collected. So, as we read this problem, diethyl ether is made from ethanol according to the following reaction. We have 2 moles of ethanol in the liquid state that reacts. So 2 molecules, you could say 2 molecules of ethanol would react to form 1 molecule of diethyl ether and water. So what's the first great care when dealing with reaction stoichiometry problems? That's right, we have to make sure that the chemical equation is balanced. So let's attend to that duty. All right, so we have 2 times 2 here, 2 times 2, so that gives me 4 carbons here. And then we have 2 times 5, which is 10. And then 2 times 1 here, which is 2. So 2 plus 10 gives me 12 hydrogens. And we have 2 times 1 oxygen, so that gives me 2 oxygens on this side. So I'm going to set my equal sign here, and we'll distribute this 2 through. So that gives me 4 carbons, and that will give me 10 hydrogens here. And then I have 2 hydrogens over here, so 2 plus 10 gives me 12 hydrogens on this side. I have 1 oxygen here and 1 oxygen here, so that gives me 2 oxygens on this side. So the chemical equation is balanced. So now we can get busy. In an experiment, we find that 517 grams of ethanol gave 391 grams of diethyl ether. So what this mass corresponds to is what we call our actual yield after the experiment. Okay, we obtained 391 grams of diethyl ether. So that represents our actual yield. That's what we collected. So they want to know what is the percent yield in this reaction. Okay. Percent yield. Percent yield. Don't get this confused with percent error or experimental error. The percent yield is the actual yield. That's what we collect after the reaction is complete, divided by the theoretical yield. That's the calculation we can do before we even start the reaction. In fact, the theoretical yield is the maximum amount of product that we can make. And so that ratio between actual yield and theoretical yield times 100 gives us percent yield. Okay. So what we got to do in this problem, we already have the actual yield. What we got to do is we got to find the theoretical yield, the number of grams, right? And then we will be able to calculate our percent yield. So let's go forth here. So we want to calculate the number of grams of diethyl ether, which by the way is a common organic solvent used in the organic chemistry lab. So diethyl ether, we're looking for the number of grams of that. Well, where do we start? Well, we want to start with the number of grams of ethanol here. If we have a number of grams of ethanol equaling 117 grams, so we're going to start here. So we're going to say 117 grams of ethanol. Okay. And what do we have to do? Remember what I said, guys. If you're in grams of a substance, you need to get in moles of that substance. So that will allow you to get in moles of the other substance via the mole ratio. All right. So we're going to convert the moles of ethanol grams of ethanol to moles of ethanol. So for 1 mole of ethanol, that corresponds to 46 grams of ethanol. All right. Remember, you got 2 carbons here, so that's 2 times 12 grams. You got 6 hydrogens, so that's 6 times 1 gram. And then you got 1 oxygen, so that's 1 times 16 grams. All right, and so this is equal to 24 grams. That's equal to 6 grams. And this is equal to 16 grams. So that gives you a total of 46 grams. And that is, of course, equal to 1 mole. And so we use that as a conversion factor. Remember, I said do not use the stoichiometric coefficients to calculate molar mass. I repeat, do not use the stoichiometric coefficients to calculate molar mass. Once more, do not use the stoichiometric coefficients to calculate molar mass of your substance. The only time we want to use those stoichiometric coefficients, and I'll put a 1 here because it's understood as 1, is when we're going from moles of one substance to moles of another. So the mole ratio here is for 1 mole of diethyl ether. Let me write that here. That has 2 moles of ethanol. So it's a 2 to 1 mole ratio here between ethanol and diethyl ether. Okay? And so I'm going to use that as a conversion factor that will allow me to go from moles of ethanol to moles of diethyl ether. Okay, guys. So now what we have to do is calculate the molar mass of diethyl ether. Well, I know that this corresponds to 29, and so I have 2 of those, so that's 29 grams times 2. So that's an ethyl group. I have 2. And so that is going to give me, of course, 58 grams here, and then I have 1 oxygen, so that's 16 grams times 1. So I write 16 grams here, and that gives me, look, 74 grams, and that is equal to 1 mole of diethyl ether. And so I'm going to multiply the moles of diethyl ether times the molar mass of diethyl ether, and that will give me the number of grams of diethyl ether, which is going to correspond to the theoretical yield. That's right, guys. We're calculating the maximum amount of product that I could make from this reaction. All right, so the moles of diethyl ether cancel, and I'm left with grams of diethyl ether. So when I carry this calculation out, I'm going to say 517 times 1 times 1 times 74, get that product, and then divide by, open parentheses, 46 times 2, close parentheses, and that gives me the answer. That gives me the theoretical yield, which is 415.8 grams. This is your theoretical yield. This is the maximum amount of product that you could make from this reaction. Doesn't necessarily mean that you will get this maximum amount, but theoretically, this is the maximum amount. Okay, so now we're going to employ our equation right here. Now let's calculate the percent yield. The percent yield is simply equal to our actual yield. Remember, we collected 391 grams of this diethyl ether, right? But we calculated that we could get a total of 415.8 grams. I guess I could have rounded that to 416 given the number of sig figs, but I'll hold on to this and I'll check the sig figs at the end here. And we're simply going to multiply this by 100. And so when I divide 391 grams by 415.8 grams, that gives me 94.0% times 100, of course, gives me 94.0%. And this, my friends, is the percent yield for this reaction. So whenever you are calculating the percent yield, it's the actual yield divided by the theoretical yield times 100. Now, remember that if you have to identify your limiting reactant, right, then you calculate the theoretical yield always based on the limiting reactant, okay? And then once you have your theoretical yield, you divide that into your actual yield times 100 to get your percent yield. As always, I hope these videos have been beneficial to you. And as I always say, happy studies.